all, I am Rahul, Assistant Professor at MLR Institute of Technology. Full form is Mari Lakshmi Institute of Technology. That is the first campus which is located in the Dundigal near Kandimaisam X Road, via Secunderabad we can reach Secunderabad. That is one of the shortest route. So I am Assistant Professor. I am pursuing my PhD in VLSI at KL Hyderabad, that is the Aziz Nagar, and I am about to get my PhD. So I have done my BTech and MTech in Aurora, Astra College, Aurora Scientific Technological and Research Academy. That is located near Bandlaguda. That is near Sendra Guta, where Charmila. So that is the thing actually. And the schooling I have done from Oxford School and Venkateswara Government School. And intermediate from Sri Chaitanya Junior Kalashala MTC. And BTech and MTech was from Aurora Astra. And PhD from KL University from Vijayawada Guntur. And after that I shifted to Hyderabad, KL Hyderabad, Aziz Nagar. So I'm going to give some basic important concepts of VLSI design. Okay, now the first thing is the transistor, the core of VLSI. So the transistor, the upgraded version is the MOSFET. The upgraded version is the MOSFET. And there are just two types, like transistor BJT. Two types, N-type and P-type. Like that MOSFETs are having a N-MOSFET and P-MOSFET. BJT has 3 terminals, base emitter connector. Here we have 4 terminals. One is the terminal you can say, that is substrate indicated by B, remaining are gate, source and drain. Second important point in VLSI is CMOS technology. What does this CMOS stands for? CMOS stands for complementary metal oxide semiconductor. Metal oxide semiconductor technology. The technology is about putting the theory into practicals. So always I suggest the current trends go according to the blooms, whatever you study. That is, blooms is nothing but first you have to remember, let's understand, analyze, apply, evaluate and create. 6 levels like pyramid should be there. Like that you have to analyze the things. And English LSW technique is also very important. Learning, speaking, reading and writing. Reading and writing. LSW, writing and reading. That is also very important technique. To be analyzed and implemented in day-to-day education system, so that each and every student can grasp the concepts, okay, and analyze based upon a particular phenomena, particular flow. And the third important point is the VLSI design flow. VLSI design flow. So VLSI stands for very large scale integration. So that is the main thing. And from sand to silicon. That is the main purpose of VLSI design. The example of VLSI design is nothing but you can say the subscriber identity module, and also various other things like microprocessor and a microcontroller, etc. It's the logic gates. Next is the logic gates. So we have different logic gates like AND gate, OR gate, then NOR gate, NAND gate. So there are different logic gates. AND is nothing but multiplication, you can say. OR is nothing but addition, you can say. NAND is nothing but negation of AND. That is the negation of multiplication. OR is nothing but the negation of addition. That is the universal gates, you can say. What are the universal gates? Universal gate is nothing but the NAND and NOR. NAND gates and NOR gates. Means that what is the meaning of the universal gate? It is nothing but every circuit can be built by those particular gates. And okay, and there is one more term of combination circuit and sequential circuit also. Combination circuit and sequential circuit. Okay, right? That is the thing with respect to the and with respect to the phenomenon. That is the circuits. Okay, now. And one more important point is nothing but we have RTL design and very low. RTL design and very low. RTL design and very low. So what is RTL full form? Resistor transistor logic. Resistor transistor logic. Resistor transistor logic. Okay, now. Right. So we have one subject also. RTL design and very low. When I say there is one subject I remember. The subject is DGTV. Digital design to very low. Digital design through very low. Digital is nothing but it is a new phenomenon. Okay, now, so for example, like UPI, Unified Payment Interface. That is nothing but what is the digital phenomenon, digital payment phenomenon. Okay, now, so where we have to scan a barcode. Okay, now, after scanning, it will ask, okay, now, the amount to be paid. So we can pay the amount and what is the reason for the pay of amount. Comments you can write it. And after write it, you have to pay. And it will add some PIN number. That's an identification number, whatever we have set as a password. So that before that also, if we task, we have multiple bank accounts and last which account to be activated, to which the money should be transferred. So that particular account should be activated and it should be transferring the amount on the PIN entrance. So like that, the amount will be transferred digitally through Wi-Fi, technology. Wi-Fi is nothing but wireless frequency. We have another technology which is in a Bluetooth technology, which can't be seen, but that is done. One more good technology is photo technology, photo image grasping, photo and video grasping, with video and audio also grasping. That is also plasma phenomenon. And one more important point of very VLSI is a timing analysis. Starting timing analysis. A short form is at a ST, which has concept of setup time, hold time, clock speed, propagation delay, etc. Setup time means the time taken to take the uniform paths. Setup time. Okay, now hold time, the time taken to maintain the stable output. That is called hold time. Okay, so that delay is nothing but the actual time to be reached minus the time it has reached. That is called delay time. For example, it has been scheduled to reach at home at around 8 o'clock, but I came at 8:15. So what is the actual time I came? 8:15. What is the time I have to arrive? 8 o'clock. 8:15 minus 8 o'clock is 15 minutes. That is the delay. 15 minutes is the delay. So what is the delay in terms of propagating a signal? Signal is nothing but information which carries information. Signal can be of different waveforms and different shapes. Different waveform presentation. So like sine wave, square wave, sawtooth waveform, as well as the triangular waveform, etc. So based upon our convenience, we can pass a signal with different signal shapes. Okay, now next is power optimization. Okay, now power optimization. So power optimization is a very important concept. Okay, now so the concept is clock gating, multi-VDD and power gating. The prediction of power without consuming, okay, now performance. So these are three techniques. What are the techniques? Clock gating, multi-VDD and power gating. Clock gating, multi-VDD and power gating. Multi-VDD means multiple drain voltage, drain supply voltage. These are the techniques. Okay, now for power optimization with good power, with good performance. So VLS design. Okay, now eighth one is a layout design and DRC. Layout is nothing but internal representation of a design. Okay, right, internal representation of design. Okay, and the DRC is nothing but design rule check. So minimum spacing, minimum width, minimum length, these are the rules. Layout design is nothing but internal representation of particular design. Schematic is nothing but only a line representation. Stick representation is nothing but only the outline representation of schematic without the symbols, but a stick representation. So each and every MOSFET, okay now, consists of one polysilicon. Okay now, P MOSFET means to integrate P diffusion, and MOSFET means to integrate N diffusion. Like that, you can get it. And signal integrity is the ninth important concept. Signal integrity. Signal integrity. For reliable operation, you have to maintain signal integrity. Factors like noise, crosstalk, and others can affect signal transmission. Okay, now. Parasitic capacitance means dependent capacitance. Capacitance is nothing but the phenomenon of storage of energy. Passive stores energy. Okay, now signal integrity is the essential for reliable operation, right? And the 10th one is the testing and verification. Testing and verification. Testing and verification. So by verifying the device functionality, you can say it as a correct operating concepts. Say you can say it as a correct operating conditions. You can say it as an you can say it is in a correct operating condition. In silence software, we have front end where we can write a code different forms like a behavioral form or otherwise a structural form, data flow form, and we can execute that particular code. Okay, now after that we have to evaluate or we have to analyze the particular inputs. To a particular output. For example, AND gate we have written a program. 0 means it will be 0. 1 means 0. 1 means 0. 1 means if you get for one high and high input, you will get high output means, and that is all outputs you will get about the particular input. Then it is said to be correct verified design of an AND gate. Of an AND gate. An AND gate. So that is the important thing. In the front end tool, you can say front end software that is silence. Back end is a cadence as well as a not etc. Cadence synopsis etc. So these are the very important concepts of VLSI design. So VLSI in one word we can describe through MOSFETs. Like body to assume as VLSI design. And then cell is a basic part of the body. Like VLSI design basic part is a MOSFET. By integrating several MOSFETs, you can get a VLSI design, any VLSI design. Okay, now by getting NAND and NOR gate, integrating NAND and NOR gate in different forms, you can get a n number of or any design, any designing VLSI, using universal NAND and NOR. Universal NAND and NOR. So this is about the first lecture, or you can say introductory lecture about very important concepts in VLSI design. These are EDC as well as the DSD. EDC stands for electronic device and circuits, and DSD stands for crystal system design. Okay, now so in VLSI you have to be good with respect to coding as well as you should be very good with respect to back-end designing also. That is pick and place of components from various libraries and connecting them to wires. Okay, now and verifying the circuit condition by giving the different analysis like transient or DC or noise or AC, parametric, etc. The analysis we have to give several inputs and we have to test the output. Split screen of input and output and so nowadays I see in we are getting this CAD software. That is what we can say. We are getting a leak version. Okay, now so that supports only for i5 processor, high-end processor itself. i5 processor it is not supporting. Okay, now i5 processor it is supporting, and microwind also one software will be there. That also software I used to study in tech. That was also useful for doing layouts. But now in education system it is not used. High-end they are using, that is current software, current design tool. And in that extra version design counter also will be there. And Synopsys is also another company offering the scans, design, layout verifications, and front-end verification. Front-end software like Xilinx will be there. Okay, and MATLAB is one more software that is used for validating all type of analysis using MATLAB programs. Cadence is maybe designed for VLSI students. In VLSI engineering, we'll be having a subject as well as VLSI lab. So in that one, we'll be having the particular data. Means we can write a program also, or we can also pick and place the components from various libraries and interconnect them. There's the functionality. Or testing the functionality of the circuit, normal circuit. Okay, now we have to go with the symbol creation of the circuit symbol. Next after symbol, we have to go with the test bench creation, and after test bench creation, we have to go with the layout generations. Okay, now. So you should have a very important sound knowledge in rules and regulations. For designing any layout. Rules and regulations for designing any layout. For main two things of layouts are, one is the minimum width and spacing. Minimum width, minimum spacing. Length, width, spacing. So these are the main things for layout design rules. So we have to follow the rules and regulations for designing a layout, and we have to continue with integrating the different layers as per the circuit diagram, like inverter for example, and we have to test for its functionality. We have to test for its functionality. We have to test for its functionality. So like that, VLSI can be made easy by analyzing with respect to different codes, different backend simulation diagrams. Okay, now, like logic gates, we have to do it. Combinations equal circuits, we have to do it. Okay, AI logic and OI logic. So what is the full form of AI logic? And or inverter. What is the full form of OI logic or an inverter? And then we have to solve different logic gates. We integrate them and test for its function. Each and every concept in VLSI is performed in that one important concept will be like a threshold voltage. Threshold voltage also will be there. The threshold voltage is the minimum voltage that is required to generate current. So you can see the diode. There is diode of PN. Other diodes PN diode is 0. It is a phase equation. Next is the half wave here are right. So got the UJT transistors, etc. Silicon transistors. All the things will be there. Okay, now, so what is the main thing we remember? So the analyze is the operation. That's the MOSFET. Two MOSFET and they are having fabrication steps. CMOS fabrication, PMOS fabrication, CMOS fabrication. CMOS is combination of P1 and PMOS compounds. PMOS means majority carriers are holes, minority carriers are electrons. NMOS means majority carriers are electrons and the minority carriers are holes. So like that we have to analyze the fabrication steps starting from the substrate, okay, now to forming the etching and the making things. Or gate source and drain. Gate you can term it as a pipe. Source is something like that figure which water storage is pipe. Main is a bucket. This is a drain. Source is a drain is bucket. Current is a water. Tap is a gate. So pressure water is minimum pressure or force is required to open the tap. So that the initial water will be in the bucket. So that is the main thing of VLSI. The fabrication, big diagram, sample diagrams, verification, testing, introduction. So like that we have to analyze each and every VLSI topics. So we will figure out mechanism. So what is a very good figure for a particular so like that analyze the subject properly with respect to software and theory and write it properly in terms of analyzing with respect to software and putting the proper words in a theoretical and a physical paper, so that the person will be giving good marks. For every answer, you should try it in a way such that you should get good, should get good, should get good view. So first for 1 mark, definition for 1 mark, diagnosis for 1 mark, work by for 1 mark, definition. Like that, every single line is schema. Answer. Like that, you have to first analyze the schema for each and every question. What is the question? What is the schema? And write the answer. What about the previous questions? Future questions, important questions, future trending questions, like subject questions. But analyze each and every topic with respect to blooms. Remember, understand, analyze, apply, evaluate, and create. And also, you have to go through the LSWL: listening, speaking, writing, and reading. So that these techniques you have to analyze, okay, now keep in mind, so that these are all are met or not in a particular topic. Next, you have to go with the exam. You have to go with the exam and write it and pen. Important questions will be high. Important questions will be high. So important concepts we have discussed in VLSA. I round it up. First important question, important concept is transfer the program of VLSA. Second is the CMOS technology. Third is the VLSA design flow. Fourth is the logic gates. Fifth is artificial design and wedlock. Sixth is the timing analysis. Seventh is the power optimization. Eighth is the layout design and ERC. Okay. Nine, signal integrity. Tenth, the testing and verification. So I will close this particular video lecture, okay, for important concepts of VLSA, 10, and some here and there some important concepts also I covered. More only I covered in this lecture. So thank you for having patience in my lecture. Have a great day.